Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in our D programming language series. In this lesson, I'm going to continue talking about copy constructors, first showing you a few just little quality of life improvements, I guess, with writing structs. And then I'm going to talk a little bit about performance and why we, again, care about how we use things like pass by reference and pass by values in a language like D. Now, we alluded to some of these topics in the previous lesson, but I want to go ahead and just show you how much it can make a difference. And with that said, let's go ahead and dive in. So first and foremost, let's go ahead and look at the D language website here, go to the documentation, the language reference, and go down to structs and unions. And then I'll go ahead and find the struct copy constructor example just so it's ready for us. So what I'm going to go ahead and do here is just review briefly what we did in the previous lesson. So we've created this struct called T here. I've got some fields. One of them is just a regular value field that we know is the size of an integer, 4 bytes. And then we have this reference type here, our dynamic array, which requires us to essentially write a deep or a copy constructor so it can properly perform a deep copy. And that was the point of the last lesson. If you haven't seen that, make sure you check back so you don't miss out on that. But again, the idea is we have our constructor that sets up our object, the destructor that'll activate and destroy our object. And mind you, this will also call the correct destructors for any of our fields as long as they've been implemented. And then we have our copy constructor, which is doing the deep copy here. It's copying the field, which is just a regular value type. So just one element there. And then it's doing the duplicate here, which allocates a new piece of memory, copying all the elements that might have been allocated here into our new object. Okay, and then we actually did a little bit of a preview here of when copy constructors are called. So anytime we pass by value some object into a function here, this will enable the copy constructor, which is our topic of today and why it's important to kind of pay attention. So anyways, with the rest of our lesson here, we went ahead and showed that we can create some new object, set up its data, print out the data, and then initialize the copy constructor, which will do the proper deep copy, and then modifying any of the data in our second object won't modify the data in the first object, right? These are two separate blocks of memory. So I'll go ahead and just run this really quickly, and we'll see that it works here. Okay, and you can already see from this example here, and we'll revisit these function calls here and how to think about them as part of this lesson here. So again, from our previous lesson, we talked about just wanting to think about every time we create an object that it's its own sort of memory space. Again, that was the motivation for the deep copy. So anyways, first and foremost, let me go ahead and just show you a small quality of life improvement here that you can do in the D programming language here that I like to do here. And instead of having to remember the type and pass it in here, we can do this little trick here. And we've done this quite a bit in this video series where we've done type of here. I could just do type of whatever this object is, which is kind of cool here. I think you might see this. Let's see if we actually see this in the documentation here. Yeah, we can actually right here. So it's the third bullet point. I must have skipped over it. But in the previous video, this is just kind of a nice thing here. That the type of the first parameter must be the same as type of this, which is, whatever our type is, but we can actually just put in type of this here. And let me go ahead and compile it. And this just works here. So, if you're having trouble just syntactically remembering all the different qualifiers on this particular variable, again, all we really need is ref here, the type of this, and then by convention, I usually use RHS for right-hand side. Things will just work here. So just a nice thing that we have here. Now, the other things I want to talk about are more performance related in this video here. So let's go ahead and just do a little experiment here, where what I'm going to go ahead and do here is let's go ahead and create this object. And again, I'm going to create this function here, and it's just going to make a copy of this object every time that it's passed in here. Okay. Now, in order to make this more interesting, let's go ahead and pass in some values here. And let's make this relatively large, this dynamic array that's part of object one, mdata. So let's just create a regular for loop here, something like this, size ti equals 0, I less than 100,000, I plus plus, and we'll just append some elements to it here. How about I, something like that, okay? And let's just go ahead and see if this works here. So we'll go ahead and just run this here. Whoops, let's see what I do here. Append I. It's a u long to an int that's the size of size t here. So I could let's just go ahead and cast this to an integer, again, being explicit in the D language. And we see that this, prints off a really, really large array here. So let's get rid of our prints here. We're pretty sure that our object, again, works with a deep copy. And we can see that it is very, very large here. Okay. So let's do something like that. Okay. So we can see that this runs here. Now, let's just go ahead and time this program here. Now, in order to time this, I'm going to have to go back to compiling our program, which we haven't done in a while here. So it's a good little review here. So we're going to pass in the DMD compiler here and our output file, which is the program here. Okay. Now let's just go ahead and run it. It runs here. And let's time it here. Okay. Now we might have to make our workload significantly larger here. So let's go ahead and make this much, much larger here. So it has to do a very large copy here. And I'm just going to append the value 100 here. Okay, every time here. So changing the experiment just a little bit here. So recompile, rerun it, and it takes about, somewhere on the order of, if we run this a few times here, maybe 33 milliseconds here. An actual CPU time, 28 milliseconds. That's coming in relatively consistent, with some noise here. So in the 20 millisecond range here. Now, where's the time in our program dominated? Well, it's possible that this just takes a really long time to set up this array here. So what I want to go ahead and show you where the performance difference could potentially be here is, let's create another loop here. And I'll do the same thing here. Size t equals 0, I less than 1,000, plus plus I here. And we're going to go ahead and create or make 1,000 calls to this foo function. And it's absolutely reasonable that you could have a function in a loop that's called all over and over and over again, passing some very large object. And that's the point here. We're passing a very large object, this huge array that's being accumulated here. And we need to do this, thousands of times or many times, maybe in a loop that's running over and over again. Okay. So I want to make sure that this part of the program dominates a little bit more here. So let's go ahead and compile this. Let's go ahead and run it. And it's going to print a lot. And again, I want to be careful with this experiment here. Let's go ahead and get rid of our printout operations here. And let's go ahead and remove those. And we could see that this took a little while to run here. Okay, so this is a little bit of a better benchmark here, I would say. Let's just go ahead and see how much time this program takes here. Okay, because now if we observe what the program is doing, and again, I'll be careful. My hands are off on the keyboard. There's lots of different ways you'd want to perform this experiment very carefully when it comes to performance. But, this is taking, 15 seconds of real time, 6 seconds on the actual CPU. And then, the CPU or the operating system was doing something else for 8 seconds. Okay. So what was the system doing here? Or I should say, why did this program take 15 seconds to run, but in user time in 6 seconds? What was the operating system doing this whole time? Well, it was probably allocating tons and tons of memory behind the scenes here, okay? Where it went into our actual operating system, allocated some memory, and this just took a bunch of time here, right? Because every time I'm passing by value here and making a copy here, a lot of time is taken here. So let's see what the difference is if I pass in by reference here, okay? And I'm just going to be explicit here that I'm going to pass in by reference and not modify the object here. Okay, that's usually the case where you want to pass in something by reference. You just want to take a look at the data, maybe print out some data or whatever here. Okay, let's go ahead and see if I recompile this and on the first run, so it's a new program here, how much time this takes. Okay, only like a few seconds here. So clearly when we're making lots and lots of copies, this is expensive. This takes a lot of performance away in our programs here. And D is a language that allows you to get very high performance programs if you so choose. We just have to, again, think about or make these decisions. So what are the fixes here? Well, one is we can just, and let's go ahead and label these out here. I'll get rid of what we had from last time here. Let's go ahead and first and foremost, just one, pass by reference if data is not mutated to avoid copy constructor. Okay. And I don't know if I actually have any other rules other than that, because that's just literally what you should be doing. And you can see the huge performance increase, right? We're hardly allocating here or doing any unnecessary work in the operating system. That's usually a good indicator that, yeah, in this system time, we just spent it allocating memory on the heap, okay? But the second thing is, if you know you have an object and it just shouldn't be copied because it's taking a lot of performance away, or you want to think about this or try to catch where a copy is being made, you can use a profiler, and eventually I'll show you the deprofiler. You can do little tricks here, like, printing out, hey, copy constructor was called. Or what you can just do, which I think is neat here, is, again, if you know you have some super large object here, is let's go down and just show you this trick. And we saw this with constructors, I believe, briefly, is we can actually just disable our copy constructor, okay, with the @disable here. So let's go ahead and do that here. I'm going to go ahead and just comment out this code here. And what we'll go ahead and do here is just type @disable, which is an attribute here. And it follows the function signature, type of this, okay? Just like we did before. And now we should get some compiler errors telling us that, hey, we don't have a copy constructor, so why are you using this at line 45, for instance? So let's go ahead and get rid of that here. Okay, let's go ahead and see if we can compile now. And it's saying, let's get rid of all these things here. So see if we can compile. We can compile. And then if we run this, it will run quite fast. Okay. And let's go ahead and, again, just to uncover, are some copies being made here? Which they are. Again, this is the other place of where copies are being made on this function call. Okay, so disabling your copy constructor is, an option. Again, if you just want to capture, I've seen developers use this little trick just to see, like, hey, are there tons of copies being made somewhere when we didn't intend them to be used? In that manner, that can be one way to just hunt for things. But again, sometimes this is also just a design pattern as well. If you want to make sure you have exactly, one object, or that objects must be explicitly created and built out for whatever reason. So now we know about that. All right, folks. So with that said, I'll post this lesson on, as always, courses.msha.io if you want to track your progress. This one follows nicely after the previous lesson. So make sure you're subscribed or following along on here, however best helps you learn the deep programming language. But I hope this lesson helped you learn a few things just about performance, right? We did a tiny little performance experiment just to see where copies are being made and how expensive they can potentially be to do that deep copy every time. Even if we're doing lots of shallow copies, that could be expensive over time if we have lots of objects. So it is something we need to think about, and it's just something to be aware of. Again, why the purpose of this language has things like ref or passing by value by default. And this applies to other languages as well, but it's just really cool to see how we can fine-tune things and get a lot of performance out of the deep programming language. So anyways, folks, with that said, I hope you enjoyed this lesson, and I'll look forward to seeing you in the next one.